Good morning.
Good morning, sir.
Good morning, sir.
Good
Good
morning,
morning,
sir.
sir.
Good morning, sir. GM, sir.
Good morning, sir.
Good morning, sir.
So when you will come to the campus?
After it, sir.
Then
The 21st.
so, so next class will be the last class. I think the last class should be taken in online offline or I will complete the class online mode and offline mode. Viva will be there. That will be better. The syllabus should be ended fast, no? Yes or no?
Yes, sir.
Sir, please complete the plates in online. Like,
Why? Who are you? Say this one.
like, sir, we have 5 plates done. It's like
Who are
2
you?
plates remaining.
Who are you to tell this one? Whether it will be completed online or offline, who are you?
Like, sir, it will be very helpful in our home. Every instrument in our home, like the big board, hefty big board, it is impossible to carry that in that college. And the other, like tea.
If I declare that offline, then you will find that yes, everything will be possible for you to take to bring that one in your
No,
hostel.
sir. After the college reopen, we will submit the plates in physical.
So
The done
that
plates.
I am telling that one. So why are you interrupting me?
Okay,
I
sir.
want to tell that one.
Okay, sir. Actually, sir, previous day we got a mail
I
like,
also I also tell that one. Previous day and today, this is today. I am telling.
okay,
What
sir.
are you disturbing? Isometric projection. Today's topic. And then you have this problem sheet. No problem. Have you taken the print out? The isometric projection.
Yes,
You
sir.
open
Yes, sir.
you open this page. So again, 3 problems you have to complete. So first, we follow the general lecture. Then 2 problems I will discuss here. 1 problem you have to do by yourself. 3 problems you have to complete on the drawing sheet and you have to submit. Here, so this is a queue. This is a queue. Now, if it is placed like this one, this surface will give the plan and this surface will give the elevation. So that means plan will be a square, elevation will be also a square. So to have the three-dimensional idea about this object, we need 2 views. One is plan, length and breadth. Another one is elevation, which will give the dimension of height of that object. Up to this it is clear. So if it is placed like this, the square surfaces will be projected here as square. Now, if it is inclined, it is visible. So if it is inclined like this, what will be the shape of this surface, top surface? That will become rhombus. So it was a square, now it is rhombus. If it is inclined. Again, if all the faces are equally inclined, so these three faces will be visible to us, which will be inclined 120 degree, because total is 360 degree. If the surfaces are equally inclined, so angles will be 120 degree, 120 degree, 120 degree, no problem. Square faces will become rhombus. Up to this it is clear? Up to this it is clear? Anyone please?
Yes, sir.
Yes, sir.
So what will be the shape of that one? First draw. If it is inclined equally, all the three faces will be inclined equally. The square faces will become a rhombus. So what will we say in three-dimensional view? You follow this one. So this cube now will be visible in a single figure, 3D figure, like this one. This angle is 120 degree. This will be 120 degree. This will be 120 degree. Simple. Suppose this face is A, B, C. So BD diagram, it will be student or projected plane. BD diagram. Anyone please?
The projectile then.
Since it is parallel, so it will give its student. Now, ABCD, which was initially square, now it becomes rhombus. Inclination is 120. So what will be the inclination of this one? Anyone please? This is 120. So what will be the height of this? Rhombus. Anyone please respond?
120.
120. What will be this again? This one.
60.
60.
So what will be this angle?
30.
What will be
30.
That means this side will be inclined 30 degree if all the surfaces are equally inclined. This view is isometric. So the arrow sign will be here. It means that this edge will be this direction and this edge will be this direction. This will be the height, so this is the height. This is the height. All other sides are parallel to these three lines. Clear? These three lines are called isometric axes. So in isometric projection, all lines will be parallel to the isometric axis. Now, interesting thing is that this angle is 30 in isometric view. 30 degree. If it was square, what is the value of that angle?
45.
40. Very good. So this is 45 if it is square. So this A will be here in case of square, that means this side, suppose BA1, BA1 will be shortened by this amount. The inclination is this one. Now it is clear? It is clear now? So if I draw a horizontal line, this line inclined activity will be corresponding to the isometric view. This line inclined 45 degree will be corresponding to true length. This scale is known as isoscale. Isoscale. So suppose B, this one is say O, this is A, and this is say A1. So you tell me that BA will be shortened with a ratio. What is the value of that? Anyone please? Take this two triangle, calculate and tell me. Very simple. That is BA by BA1. What will be the ratio?
Two is to three.
Yes.
2:3, sir.
Anyone please? Root 2 is to 3, is it?
Oh, sir, 2:3. 2/3. Root, not root.
Eh?
2/3, sir, not root.
Cannot follow you. Any other student?
Sir, sine 30 upon sine 45.
The ratio is root 2 is to root 3, yes or not? A is to BA1. This triangle 30, cos 30, BO by BA, cos 45 degree, BO, BA1, BA by BA1, A1. What is this? What is the remaining value of this?
Sir, root 3 is to root 2.
If it is BA1 by BA, if it is BA by BA1, yes. That means in isometric projection, length will be shortened with the ratio root 2 is to root 3. That is very simple. There are two terms here. One is isometric projection. In some problem, you will find that you have to draw isometric projection, and in some problem, you will find that you have to draw isometric view. So one will be isometric projection, another term you will find isometric view. You try to remember isometric. In case of isometric view, the true length of the object and the true length of the projected view will be the same. In case of projection, isometric projection, the length will be according to the isoscale. What does it mean? Suppose this is the plan, say A, B, C, D. What will be isometric projection? What is the rule? First, this will be inclined, arrow sign is there, so this will be along this direction, 30 degree, this will be 30 degree, height is not here. This view will indicate the isometric view. So this will be equals to BC, BA, this will be equals to BA, and this will be AB. So in this view AB is at equal in case of isometric view. But if it is required to draw isometric projection, then we have to draw the isoscale first. So this is the isoscale, this is 30 degree, this is 45. Now this side will be inclined along this direction and this will be. Now this lane, true lane, will be placed here. True lane, BC. Then we have to draw projection perpendicular. Suppose this lane is BC1. So BC1 will be here. So in case of isometric projection, this length will be corresponding to the isoscale. Similarly, AB, this is B, suppose this is A. So since this is square, shape will be there. Draw parallel. This will be parallel to this one, this will be parallel to this one. So this is the view which will be the isometric projection. The side of this view or this object will be according to the isoscale. Now up to this is clear? Up to this is clear?
Yes, sir. Yes, sir.
So if in the question it is given that you have to draw the isometric projection, then you have to draw the isoscale, and from that isoscale the length will be taken. In case of isometric view, there is no need of drawing the isoscale. Both the lengths will be equal. Now, suppose this is plane. And this is elevation. Arrow sign is there. What will be the shape of its isometric view? First, so this side will incline, this side height is there, so this will be here. Isometric axis are now drawn. What will be the other lines? Other lines will be parallel to the isometric axis. So if plane and elevation is like this one, the isometric view will be this one. Is it clear?
Sir, what does the arrow means?
Arrow means this side will be inclined along this direction, this side will be inclined along this direction.
Okay, sir.
If the arrow is here, it will be along this direction, it will be along this direction. If arrow is not there, you can take any place.
It's a point of view.
Yes. Now if pentagon is there, so A, B, C, D, E. What will be isometric projection of view? So we have to complete this one, a rectangle or a square. So D1, 2, 3. So D1, 2, 3. If the arrow is there, so it is possible to draw the isometric view. For B,
Yes.
this will be B3, B3, this will be B1, B1, this will be 2. So B1 to 3, B1 to 3, this will be 3, sorry. Now C, so 3C, this distance we have to measure, this distance we have to measure and put there. So that point will be C. Then E, so 2E, so 2E. Then D, 2D, 2D. A, 1A, 1A. This distance will be equals to this one. Now ABCD is available. You join ABCD. So this is the isometric view or isometric projection of a pentagon. So what is the method? First we have to complete this one. D1 to 3. Then we have to draw the isometric view of this one, D1 to 3. Then it is possible to locate all these points. Here, but if it is circle, as you draw on your graph class note. What is known to us? Square. So you complete this square. Now it is rhombus. Clear? So midpoint of this one, you join. Midpoint of this one, you join. Similarly, midpoint of this one, join. Midpoint of this side, you join. With this point as center, radius equals to this one, you draw an arc. With this point as center, radius equals to this one, draw another arc. With this point as center, radius equal to this one, draw this arc. With this point center, radius equals to this one, draw this arc. So circle will become ellipse, and this method is called four center method. Four center method. One center, two center, three center, four center. Shall I repeat?
Yes, sir.
So first, suppose this circle is. So first, we have to complete this square. Then we have to draw the isometric view of this square, which will be around. So from this point, the midpoint of this side will have to be joined. Similarly for this one. For this one, for this one. Is it clear or not?
Yes, sir.
So midpoint of this, midpoint of this, you join. Midpoint of this side, midpoint of this side, you join. This is one center, two center, three center, four center. And with this point center, radius equals to this one. You draw an arc. Center, radius equals to this one. Draw center radius equals to this one. Draw a center radius equals to this one. Draw so circle will become an ellipse, and this method is called force center method. Force center method. So if have you drawn?
Yes, sir.
Yes, sir. Drawn.
Shall I proceed?
Yes, sir.
Yes, sir.
আমি ক্লাসে আছি এই দেখো পড়াশোনা করছি so if plan is this one, elevation is this one, what is the name of this object?
Cylinder.
Cylinder. So now you have to draw the isometric. So first, this circle is also present in the upper face. So this is the isometric box first. So this face and this face. Circle will be there. Circle will become ellipse. So
Yes, sir. Force center method.
yes, with the help of force center method, you draw these two ellipses and join the common lines. And you tell me whether it is possible to draw by you or not. So this will be force center method very simple. This one, this one, this one, this one. Here also ellipse will be there, and you join. You draw the ellipse for the lower face. And
Sir, is the lower ellipse is dotted?
first you draw the ellipse, then I say which will be dotted or not. First you draw this one, this one. Automatically this portion will be done. Then if the elevation is this one, what is the name of this object? What is the name of this object?
Cone.
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 Yes. The height is there on the midpoint of this. Height is here. So this tangent from this point, this tangent will be there. So this will be the isometric view of the cone. So we first complete these two figures on your classroom. Then I will discuss the problem. So again, I think you remember that still I am telling that this will be drawing sheet. This will be the border line. This will be your nameplate. Heading will be isometric projection by mechanical type. Then you may divide or may not. One problem, two problem, three problem. Clear? You have to give the dimension and therefore write here all dimensions are in millimeters. Only isometric view will be drawn on the drawings. Figure number 1. You follow this one. Figure number 1. So you have to draw figure 1 Figure 3 and one curve. Figure 6. So you write figure 1, figure 3, figure 6. Figure 6 curvature is there. That is why we have to draw one of these objects. So I will discuss figure 1, figure 3 here. You have to draw figure 6 by yourself, and I am sure that there will be no problem for you. So first is figure 1. This is left side view. This is the front view, and this is right side. Clear?
Please repeat, sir.
Plane is not here. That means the height of the object, width of the object in one side, and the length of the object is one. So it is possible to draw. So first arrow sign is there. So first 120. This is 120. In this direction 60. So this will be 60. What is the height? 85. You write here 120, 60 on your rough class. You write, otherwise you forget. 120, 60, and the total height is 85. So complete the isometric box. Complete the isometric box. You first complete, then I will discuss it. Your rough note is right here 120, here is 60, the height is 85, like this. Then 25 height, a line is there. The line is there, height is 25. Here, then from the midpoint of this edge, midpoint of this side, and midpoint of this, so midpoint of this, one line will be there, and 15 width. 15 width, 7.5, 7.5 on this axis, and 15 width. Then this 8 width will be there. So from where? This point is 16. This point is 16 midpoint. So here it is 16. So from this point, the line parallel to this one, and the line parallel to this one. Hello. This is clear or not up to this? Now it will be projected vertical. Vertical means this parallel to this. So this point is now here. This point. Width is 8. This will be 8. This will be 8. This width is 8. Similarly for this place, this width is 8. So it is joined with this point, joined with this point. Joined with this point, it will be joined with this point. Since it is three-dimensional view, so it will be, this place will be visible like this one. This will be joined with this point. This will be joined with this point. And one line will be parallel to this one. Parallel to this one. So this face is now complete. This one is now complete. Now the green portion, the dual portion, green portion. The angle in isometric view, angle will not be there. So how it will be drawn? You have to draw in the last page that this is 15, this is 15, height is 10, this height is 10. So you have to draw 60 degree here, but in isometric view, this distance will have to be measured. This distance has to be measured. So this will be 10, this distance is known, 15, this distance will be measured from this one, you join this. Similarly for this case also. Similarly for this case also. This is clear or not? This is clear or not? So the thick line will be your isometric view. Is it clear or I will repeat?
Yes, sir. Repeat, please.
Repeat. So first, we have to complete the isometric box. For this figure, this will be 120, this will be 60, and the height is 85. A very thin line to complete this isometric box. Very thin. Now height is 25, the thin line is there. This is 25, this will be 25. Now this axis of this one, will be midpoint of this, and it will be joined to midpoint of this place. That means this will be the axis, and 15 width will be parallel to this one. Now it is clear. But
Yes,
we have to draw this one. We have to draw this one. Like this in isometric view. So this will be parallel. This will be parallel. That means all the lines will be parallel to isometric axis. So the distance, this distance should be known. Here it is given a clue that is 16, and that will is 16. That distance 60 line is here, which will touch this inclined line. So this distance is 16. So line means parallel. We will touch this line, again it will be parallel. So from this we have to project. So this point will be corresponding to this one. Then it is possible to draw 8. This will be 8. Again it will be 8. So these 2 points will be joined. Since it is isometric view, this face will also be visible like this one, and one line will be parallel to this because it is a single object. Now for this one, angle is there, but I told you that in isometric view there will be no angle. So how it will be presented? With the help of the distance. What is the distance is there? 10. So this is 10 that is given. Now here we have to draw. So this is 10. This is 15 given. Angle is 60 degree. So this will be 60 degree. That means this distance is possible to locate. This distance is possible to locate. So it is possible for us to locate this one, to locate this one. Now it is clear. Similarly for this one. Similarly for this one. So thick line will be the isometric view corresponding to plan and elevation, which is given in figure 1. Which is given in figure 1. So this will be the thick line. Now it is clear. You draw this one, then I will discuss figure 3. Shall I proceed first to figure 3? Shall I discuss figure 3?
Yes, sir.
Do you have any book of engineering drawing? Hindi part? Actually, it is available in library, but it is not possible for you. Collect this one. Now, figure 3. In online, it is not possible to ask to monitor whether a student which is submitted by that student will be drawn by himself or herself or not. But in offline, it is possible. Okay, figure 3. This is plan and this is elevation. Plan elevation, front view, top view, front view. Arrow sign is there. So this is 70 and this will be 100. So first complete isometric box. This is 70, this will be 100. 100 and 100 these degrees. And this will be 70. Height is 70. So we complete this one. Complete this isometric box. Thin line. On a drawing sheet, you will draw this isometric box thin line. But you have to show this one so that you can understand that yes, isometric box has been drawn, and then with the help of the conception, you have to draw this. Now this in plan, that means top surface. So this distance is 30, so this is 30. The line is there, parallel to this. The line is there, parallel to this. First. So we have to put this surface, we have to create this surface. Joining this. Now this is 20, 20, 20. So 20, 20, 20. Now for this one, middle one, a dotted line is there. It indicates the grooving is there. A grooving is there. This height is 10. So this height is 10. So this will be 10. That means since this height is given, so this surface will be created at a distance 10. If it is not given, then it will be joined. But the height is there 10. Up to this it is clear, or I will repeat again.
Sir, please repeat.
Please repeat. Okay. First, you try to understand, to draw the isometric box first. This is plan, this is elevation. Arrow sign is there. That means the thin line, horizontal line, this will be inclined, this direction, length is 70, this is 30 degree incline, but the length is 100. What will be the height? Height is also 70. It is okay?
Yes, sir.
Now you complete this isometric box. All lines will be parallel. Now up to this it is okay. So this is the plan. That means top surface. This distance 30. At a distance 30, a line is there. The line is there, which is parallel to this one. That means parallel to this one. From the elevation, it is clear that this line will be joined with a point 10 meter. This is 10. This is 10. For this surface, it will be 10. So this 30 and 10, this surface is now created. This face is now created like this. Now up to this is okay?
Yes, sir.
Yes, sir.
So here 20, 20, 20, follow 20, 20, 20. And this is 20. This will be parallel to this one. This will be parallel to this one. Parallel to this one. So 20, 20, 20. For mid one at a depth 15. Dotted line is there. So this line, since the surface is now created, so for this surface, all lines should be parallel to this one. All lines should be parallel to this one. This height is 15, so this will be perpendicular. 15. This will be perpendicular, that is parallel to this axis. So this is 15. You join this one. Clear? So this will be parallel to this line will be parallel to this one, so this will be the intersection. Now the grooving is created. It is clear or not? Again, for this face, 30 height. This will be joined, this line. So this will be joined at a height 30. Since a distance is there, so it will be joined not with this point, it will be joined with this intersecting. Because this distance is there. Now, the thick line, if this will be the thick line, is it clear or not? This will be thin line. This will be thick line. Now it is clear. So this is the isometric view. From isometric view we follow whether this plane and elevation are possible to draw with the help of this figure or not? And if you think that yes, it is possible to draw, then this isometric view is okay. Shall I repeat or it will be possible for you to draw?
Repeat, sir, please.
Sir, please repeat, sir.
So first complete the isometric box to try to understand whether it is possible for you. So this will be 170, 70. Very thin line. Height is 10. This height is 10. For this surface, this line is there. For this surface, it will be parallel to this one. This distance is 30. The line is there, parallel to this. So another surface is now this surface. This is 20, 20, 20. Now for mid portion, a grooving is there. You have to remember this one. This line will be parallel to this line. The depth is 15, it will be perpendicular. This is 15, this is not parallel. It will be perpendicular. But since this line is on this stage, so this line will be parallel to this one. So from this 15 point, to draw a line parallel to this. Parallel to this. This will be intersecting. Now, again, we have to draw a line parallel to this one, another line parallel to this surface. This one parallel to this surface. So the grooving is now complete. This is 20, that is given. This is 20, that is given, and the grooving. So this will be thick line. This is 10. This will be thick line. But this line will meet at a height 30. So this will be 30. These 2 points will have to be joined. Similarly, these 2 points will have to be joined. So for this phase, this line will have a thin line. This will be thick line. This will be thick line. Now the object is in isometric view. Now I think it is clear to you.
Yes, sir.
So figure 1, figure 3, figure 6. Figure 1, figure 3, figure 6. Now I will leave. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
ठीक है
Thank you,
सर
sir.